All right. Thank you all. Thanks for joining us here. I'm Vishwanath Jakka, part of Cisco. I have my colleague here, Andres. He'll be joining us after I'm done with my part of the presentation here. So today, I would like to share with you guys on how Cisco is helping our customers in their digital transformation and their journey for adopting containers and microservices methodology in your business. So let me start with some of the broader Cisco data center vision and strategy. Then I'll talk about some of the trends that we are seeing in the market and how Cisco is helping our customers, how we are working with our partners to develop offerings for you guys to leverage in your business. So first off, digital transformation. This is something that all of you are experiencing in one form or the other. Nowadays, applications are the king. It's the center of the universe, and that's how businesses are looking at it. Developers are making a lot of decisions for you, and the reality is multi-cloud. It's on-premise, off-prem as well. So if you look at that three-dimensional picture, three-direction picture there, so the way businesses are operating is changing over a period of time. Things have gone from on-prem to public and multi-cloud. From a decision-making perspective, it was traditionally the IT team. Now that has changed to line of businesses as well as the developers themselves using the DevOps methodology. In terms of the application architecture and the deployment model, it used to be bare metal monolithic applications. Now, last few years, it has been all virtualization. And now, it's microservices and containers. And the key thing to note is that it is each of these things, they are not replacing what you had earlier. As a business, as a IT owner, you have to manage all these things together. It's not one or the other, it's all of them. So that means more work to do with the same set of resources, more challenges, more open items. So these are some of the things that our customers are dealing with and how they are going about their business. So how does Cisco look at the data center? What does it mean to run a business? So it's all about a multi-cloud architecture where the customer's intent, in turn, your application's intent, that should drive your architecture. That will be efficient, it will provide you best value and the best use of your resources. So, and it's built on the various layers from a physical infrastructure, going and then the policies and automation required to make it happen. Then it's a question of on-premise as well as public and hybrid cloud, and multi-cloud at the top where you have options across the board. How do we make it happen? We have a portfolio of products and solutions that become the building blocks for all this in this architecture, and it will provide you the value. In terms of the data center, you have UCS from a compute, HX from compute, and Nexus and ACI from a networking perspective. Then from a policy-driven architecture, you have other products in our portfolio, that's Cloud Center, ACI, App Dynamics, Tetration, to provide you the complete picture for automation, orchestration, intent-driven architecture, as well as security and analytics. So that's the broader Cisco view on how data center is evolving. This is what our customers are asking for, this is what our customers are using today, and this is what we are helping our customers on this journey. So coming specifically into containers and microservices, working with Red Hat OpenShift, we have a number of solutions available that will help our customers go on this journey. On the infrastructure side, we have Cisco UCS, Cisco HX for compute and hyperconverged storage. We have Cisco Nexus and ACI from a network connectivity as well as application-centric infrastructure. Then running on top of all this proven infrastructure, we have the OpenShift container platform comprising of Docker, Kubernetes, and OpenShift. We'll talk about it in detail as we go along. So now that we are all looking at OpenShift and containers, what is driving all this? What is that we are noticing in the industry? So from a growth perspective, based on a number of studies, there is tremendous growth over a period of time. The number of instances of containers as compared to 2016 to 2020, it's expected to be 7x growth over a period of time, with a 144% CAGR during the same period of time. Many of the businesses, enterprises, they are adopting. In fact, the 60% is already outdated now. It's close to 80% now. Many of the enterprises and the commercial businesses, they are already using containers, or they are evaluating containers and microservices for their businesses as we speak. In terms of the stack, in terms of the orchestration piece, so most of us realize that Kubernetes is becoming the de facto standard, and that is what is part of OpenShift as well. So from a technology capabilities perspective, all is good. However, when customers and the businesses try to look at adopting it, there are a lot of challenges that they are faced with, both from a technology perspective as well as from a management perspective, lifecycle, ongoing monitoring, management, and so on. So over a period of time, things are kind of settling down. Like I said, Kubernetes is addressing some of these things. So container management is a big piece. So when you're dealing with containers, you're dealing with hundreds, thousands, if not more. So that means nothing can be done manual. It has to have some proven tools and mechanism has to be in place. So monitoring is a key aspect as well. Without that, you don't know how your business is running, how your applications are running, and so on. From a storage perspective, I'm not going to go through this whole list. So from a storage perspective, so initially containers started off for applications that did not require, that were stateless. Nowadays, there are new set of applications that require persistent storage. So that's another aspect that is challenging for our customers. From a deployment and management perspective, so technology, given that which is true with anything new, it's complex, it requires a lot of skill sets, and many companies may not have that capability. So that's where the partnership we have working with Red Hat, working with Intel, and leveraging the Cisco, all the technologies and capabilities we have within Cisco, and providing the best of breed solutions for you guys to go about your business. So it's a broad ecosystem play we have here, working with Intel, working with OpenShift, working with Ansible, team within Red Hat, Puppet, and Chef from an automation perspective. So bringing all the pieces that make your journey from a deployment, day zero deployment perspective, day one, day two operations, as well as automation as you grow your business. So after all this partnership, we have built a couple of solutions out there for our customers to leverage based on the various deployment choices that customers make. I'll go into detail into this a little bit more. So with this in mind, let me talk about the underlying technology, Cisco technologies that make it ideal for OpenShift deployment. So some of the things that come to mind that would make an OpenShift deployment useful and efficient is the end-to-end architecture that is suitable for a elastic, flexible, and dynamic infrastructure. What that means is that it's not that your application layer, the OpenShift, the container layer is elastic as well as programmable. You want to make sure that your underlying physical and virtual infrastructure is equally programmable, elastic, and automatable as well. So let me start with Cisco UCS. So for people who are not familiar with Cisco and UCS, it's a unified computing system. It's a server and a system that we brought into market close to 10 years ago. So given the intent customers have with containers and microservices, you have to have systems that are not just components in itself, but also it's a holistic and intuitive system that grows and adapts itself based on your application and business needs. So UCS is a holistic architecture that was built from ground up that brings into bear the key elements that are critical to a container and microservices deployment as well. So it's a fabric, it has a fabric-centric design. It's intent-based. That will help you in defining what your applications need, and those definitions will help you to manage your underlying compute, storage, and network as well. So it's a 100% programmable infrastructure. As you manage your containers and microservices layer through your programming, you can do the same thing for your underlying infrastructure. So let me go a little bit into details on each of those 5 areas there. So fabric-centric design is all about helping customers do their business from a networking perspective, storage perspective, as well as management perspective in a central and holistic manner. From a physical perspective, a single cable can carry all this traffic in the same cable, making it easier from a connectivity, management, as well as efficiency perspective. So it's easy to scale. It's a wire once, operate forever architecture that's easy to operate. In terms of management, so intent-based management, right? So what servers, so in a typical traditional server space, the hardware is a box that has everything built into it. As your business grows, if you have to replace the server, it's a tremendous effort. Whereas with UCS, the server identity is abstracted into a software construct called service profile that makes it easy for you to grow scale your business as you grow. So migration, scaling up makes it a lot easier. It's a completely open API, is completely programmable, and it works with a wide array of tools. So we have UCS Manager, Central, and Director for not only managing your server deployments, but also your whole data center deployments. Now, the next generation offering we have is called Intersight. It's a SaaS-based management layer that helps you manage your data center across all geographies, not limited to a particular data center or geography. So this is the next generation capabilities that our customers are looking for while they are going from on-premise, on the cloud, hybrid cloud, multi-cloud. So I touched upon programmability already. So we have a number of SDKs, including Ansible and Puppet, that customers can use while they automate and deploy their systems. The other factor, like I mentioned earlier, when you're deploying containers, it's not necessarily that you're discontinuing what you're doing with your traditional applications that are either running in a bare metal environment, virtual environment, or containers. So UCS makes it easy for you to operate across the board. Okay. So with that, let me look at some of the options we have for container deployment as well itself, right? There are multiple decision choices you need to make, whether it has to be you want it to be a bare metal or a virtual deployment. Do you want it to be a hyper-converged storage or a traditional software-defined storage? Or from a networking perspective, do you want to use native networking or software-defined networking with Cisco ACI? So these are the various considerations that you might have. Based on these choices and questions we have received, we have built a couple of options for you guys to consider as you deploy and continue on your journey. So let me have a few slides on OpenShift itself, but I'll skip those since most of you should be familiar with that. So in terms of design, so we provide you detailed design guidelines for production as well as dev and test model. So going from a very small deployment with 5 or more servers or up to hundreds of servers, depending on your scale. The other thing is that all the designs that we have, you are not tied to a specific scale or size limitation. It's very flexible and scalable. You put it in place once and you grow it as you go. And this is the other option we have with hyperconverged and using our Cisco ACI technologies. Andres will talk about ACI and all the networking capabilities in the next few slides. So apart from OpenShift itself, it's not that Cisco and Red Hat have a broad partnership in the OpenStack space. I'll skip these things in the interest of time. OpenStack, we have a few offerings there. In terms of storage solutions, we have a number of design guides based on Ceph as well as Gluster for your various use cases that you can use with your deployments. With that, I will invite my colleague Andres here to talk about ACI with respect to containers.
Thank you, Vish.
All right.
So having covered compute, let's spend a little bit more time talking about networking. How many of you are running OpenShift today? Great. Who is looking to deploy OpenShift that isn't running it today? Okay, that gives us pretty much room coverage. So in working alongside customers and helping them architect OpenShift clusters, we gain a lot of experience and understanding of how networking needs to look like for OpenShift. And with that, the routing and the access control. So first key capability highlighted here is automated provisioning of all those infrastructure resources. We came to know what are the requirements for the pod network, what are the requirements for the node network, and what are the requirements for the OpenShift infrastructure resources. And all of that we automated so you don't have to touch switches or devices individually to provide connectivity for OpenShift to simply work out of the box. With that in place, you automate the install of OpenShift. You run your OpenShift installer, and at that point, you have a cluster ready to use, ready to deploy containers. Moving on, you're going to look at how do you want to secure the containers that you are deploying, besides providing connectivity. So in addition to having built a CNI plugin, which we're going to cover into more detail how the functionality of that looks like, we provide support for a couple network security enforcement mechanisms. We provide support for the upstream network policy API from Kubernetes. We bring it onto OpenShift for operators and users of the platform to have the ability to select how can pods within a project can communicate to each other. So the user has full control within upstream format on how our pods allowed to talk one to the other. In addition to that, we have a complementary level of ACI policies known as contracts, which draw boundaries around how those projects can talk to other projects and how can the cluster communicate to other parts of the network or to the outside world. So what you get is two interfaces, one that's relevant for the platform team and an interface that is underlying for the infrastructure team. Then on, you're going to want to look at how do you expose the services you deploy in OpenShift to the outside world. Most likely you're doing that today using the OpenShift router, and you have no mechanism to bypass the router. So you would, in your manifest, specify type ingress, and you would create your ingress rules manually. With this ACI integration, we give you the ability to use type load balancer the same way you would do in an OpenShift environment running in the public cloud. Typically, AWS or GKE would make the provisions of resource type load balancer to steer the traffic directly to your application. With ACI, we have the ability to bring that mechanism and offload that to the hardware to let the network be the load balancer. So you do not need to steer yourself traffic to your application. Typically, you would look at something like HSRP, VRRP, or front it with a commercial load balancer appliance. With ACI, this is entirely automated, and we provide equal cost multipathing. On the following slides, we're going to look more into detail of how that works. And building on this main three key capabilities that I mentioned, we bring in visibility and telemetry of everything that runs within OpenShift from a network perspective. So what pods making up what services are running where across the infrastructure, using what network resources, what network identities, what are the interfaces, both physical and virtual, where are they connecting to the fabric, and how are they talking to each other. In addition to that, we complement the multi-tenancy of OpenShift by doing hardware isolation of those multi-tenant constructs. And we map individual OpenShift clusters to dedicated ACI tenants, which gives you the ability to grow the number of clusters, having duplicate address spaces. You can have dedicated VRFs, dedicated VRFs within ACI. And ACI will abstract away the dedicated networking, and you would expose different address ranges to the outside world, but you don't need to figure out how do you do the connectivity between the different cluster resources. So extremely easy onboard additional clusters without having to do complex routing or switching. So let's take a little of a deeper look into these capabilities. I talked about the support for the network policy API. Once again, these are enforced using the standard upstream format, YAML files an operator would write. Once you have the specification, ACI ingests that, will render it, and push it down to Open Virtual Switch. So these rules are enforced in OVS, and for all intents and purposes, this provides you microsegmentation between pods that may be running within the same node. In addition to that, we have the ACI contracts, once again. And these are more your traditional routing and switching access control. These will be present both in OpenShift and in the top of rack. So you get those two levels of security. The main goal of network policy is, along with some of the load balancing and how you are able to make the definitions of deployments you set up, is to provide the exact same user experience you would have of running OpenShift anywhere else. So if you are bringing up a OpenShift cluster, the users and operators of the platform need not be concerned with running on ACI. For them, they get the exact same experience of running on the public cloud. They just get more dynamic resources as they requested. So ACI takes care of the plumbing. It takes care of providing the network services on demand as they're requested. One of those being the load balancing. As a feature in ACI, we call this PVR. As you see, embedded fabric and virtual switch load balancing. First sub-bullet within that is PVR. PVR stands for policy-based redirect. A policy-based redirect, all it really is a route map with the virtual IP of the service that you're exposing externally. It has the address that is reachable from the outside world into the cluster, and it has a route list of every single node that is running at least one pod for that service. This information we retrieve from the Kubernetes API of OpenShift, and we program it dynamically. So as you scale up or scale down a service, and most likely OpenShift is doing that based on utilization, or if you're doing it manually, that route list is updated automatically. If you have multiple OpenShift routers, or if you're deploying something like Istio as a service mesh, this capability gives you the ability to better scale those ingress resources. So either you have an OpenShift router or an ingress like Nginx, HA proxy. If you have Istio, you're going to have something like Envoy. But typically, you need to figure out how are you going to get the traffic there. The PVR is automatically created with a public address, or like the address that the outside is using to get to it. But PVR, what it does is for every single new incoming connection, it will load balance round robin, providing equal cost multipathing. So every new SYN packet would be load balanced across your number of ingresses, and it will provide session stickiness. So you can better scale those resources, which is a great convenience not to have to do so manually. And if there is a failure, actually traffic will not be steered, it will not be black holed. It lets you optimize some of the convergence, because you're never going to, ACI will take care of never sending traffic to a node that has failed. So we improve quite a bit. For those running OpenShift, you know this is quite a problem when a node fails and it's not detected for 45 seconds, but traffic's still being steered there. Bottom of the screen, that's the call out to the virtual networking domain. So that is the representation of everything that exists in Kubernetes from an ACI perspective. That includes not only what nodes, what pods, what projects within a project, what deployment configurations, what replica sets. It has all the metadata for this different objects. So what labels are applied, what is their endpoint group membership, what encapsulation are they using, what tunnel interfaces. And this gives you a view and a graph of the architecture of that from a network perspective. So it lets you visualize your service as a whole. I included the slide for network policy as a reference for those that may not be familiar with it. Bottom right of the screen, that's what a network policy looks like. Again, this lets you make selections of how pods within a project can communicate to each other. So a developer most likely is going to want to have its own project, or the project is going to be assigned to a team. They will have control of the network security by making definitions of network policy. This is typically directional. Currently, we provide support for ingress, and we will be incorporating support for egress as well as IP blocks. I wanted to include this for you to be able to see how the mapping of endpoint groups and network policy is performed by ACI. If you look on the left where it says cluster isolation, the moment you install OpenShift, ACI will map the entire cluster to a dedicated endpoint group. Within an endpoint group, everything can talk to each other. There is no need for the infrastructure team or the ACI team to define any access control for communication to be allowed. So that is typically what it is expected from a vanilla, fresh install. As you create projects, you will want to isolate and segment connectivity to be constrained to that project. And if you do require connectivity between those projects, it is ACI that creates the contracts in a whitelist fashion. It will only allow traffic that has been explicitly configured to be allowed. This is the project isolation. As you move on to making deployments onto a production environment, you're likely going to have to abide by compliance of the security policy, and you're going to have to microsegment each microservice, every single tier of an application, into its own respective endpoint group. So you're able to define by the set of connectivity requirements of service, placement onto a specific EPGs, and connectivity will be tightly controlled by contracts being in place. The placement of an object from OpenShift and onto an endpoint group is handled within OpenShift by using Kubernetes annotations. You make an annotation that has the key value of an EPG name, and ACI will move it onto the corresponding EPG. You notice the yellow rectangles within the black rectangles. Those are the network policies and how network policies would be enforced intra-EPG. To wrap up, I just want to illustrate what becomes the delegation of responsibilities and separation of concerns for the different users and teams involved. On the far right-hand side, you see the network administrator who remains in charge of architecting the network, saying this interfaces will be used for external connectivity to the cluster. They defined the network resources that OpenShift will consume. They provision the automation that we have created to set up everything that OpenShift will require. That includes the tenant with an application profile and the different endpoint groups for the base connectivity. Once that is in place, the container platform team, the OpenShift team, will install OpenShift the exact same way they know how. As of last week, we merged in the 3.9 installer the ACI plugin for OpenShift. Installation is performed, and there's a usable cluster at that point. The developer team will be able to build definitions of how can containers communicate by means of network policy, and they will ready to make deployments and deployment configurations. And from there on, they can annotate objects to place them into endpoint groups that have been pre-created by the networking team as they have different requirements of reachability or network connectivity for the components of their application. And there is an interface for the security team to come in and either whichever interface is relevant, be it that the network policy or the ACI contract, to make sure that the entire operation abides by rules and regulations. With that, I wrap it up. I would like to open it up to questions. Real quick, you will see there's a QR code on the chairs. You can scan it, and from it, you'll be able to download additional resources on information on both the UCS and ACI integrations.
Absolutely. No, not from OpenShift itself, but you can use Ansible scripts to both manage, automate OpenShift as well as UCS service profiles. UCS, yes, that's correct. That's correct. Yeah, we have built and published it on GitHub and also on Cisco communities. That's right. Yeah, that's right. There are a bunch of them that were developed by Cisco engineering teams themselves, but also a few of them have been contributed by our customers as well, based on what they found best for their deployments. Yep, cool.
We also have Ansible modules for ACI. We have the most extensive Ansible coverage of any networking platform. So every single workflow, every single possible configuration, it's covered in the Ansible modules we provide, and they're available on the ACI GitHub repository.
And the document that Andres was talking about, it's on the QR code. So if you download the document itself, it will give us snippets of the modules that were used as part of the design. You could start off with those, modify them as you see fit, or you can download from the GitHub repository as well. Yep. Cool.
Yep. So we provide support for great questions. So the question is, how do we handle connectivity of OpenShift nodes running on top of virtual machines? With ACI, we provide support for both OpenShift running on bare metal as well as on virtual machines on ESXi. If you have an existing ESXi integration with ACI, you simply specify it on the deployment of the provisioning for the network resources, and ACI will automatically create a port group with the required networks for the OpenShift cluster. So we'll trunk the infrastructure VLAN and the different VLANs that OpenShift requires, and you simply, from ESXi, edit settings, place the virtual machine on that port group. So we set that up for you on the distributed virtual switch, so you don't need to do it manually yourself. So there are certainly architecting considerations to be made based on the capacity of TCAM resources on any switch and any network you deploy. So that's something we would help out with. to do the most optimal configuration, but still representative of your security policy. What is really interesting is that the different models supported let you better scale because you're not utilizing EPGs for everything. You're, as a matter of fact, utilizing one big EPG for most of the cluster, and you're only creating EPGs for the subset of services that require it. And having the ability to configure network policy gives you the ability to do security without utilizing any resources on your top of rack, but doing entirely within Open vSwitch, using open flow rules, which is, there's no limit there. Yes, it's coming. We're working on it. Happy to provide you details on what the roadmap around it is.
Just so, the question was OpenStack and KVM support.
Yes, so I mentioned we provide support for nested and virtual machines with ESXi. You certainly are likely looking to nest on KVM if you're not running VMware. We're adding support for nested on non-ESXi and on top of OpenStack deployments. If it is a requirement you have, happy to chat more about it. Really our goal here is to simplify the level of effort to deploy and operate an OpenShift cluster and help you out through that journey.
Was there a question in the back?
Yeah, you mentioned telemetry. Yes. It's all the stats that are available from Open vSwitch on the top of racks. So we identify every single container as an endpoint, and we have all the network information, statistics, event logs, audit logs, networking stats, having the awareness of not just a container, but the different units and objects that make up an entire service, a project, and the cluster. So swing by the booth if you'd like to see a demo. Happy to show you how that is visualized and what is some of the information that is there.
Yep. Cool. All right. Any other questions? All right. Thank you, folks. Thanks for stopping by. And like Andres said, yeah, stop by the booth on the expo floor.
All right.
Thank you.
Thank you. Yes, certainly happy to engage in conversation to see what specific challenges you're trying to solve and how we can help out. Thank you and enjoy the rest of the conference.